And here we go. This is a review of area between two curves because we took a couple days off for final exams. And so I'm not giving you new material, but rather a material that hopefully you already are acquainted with. That way people aren't here as well. They'll be able to hopefully pick this up. So again, the most important part of today, I think, is to understand the space that you're working with. So as we look at y equals x squared minus 4x plus 4, what does that look like? It's a parabola. And actually, it's x minus 2 quantity squared, so you can see that the vertex is 2, 0. And it goes up. What does the next parabola look like? Next parabola? Yep, starts way up here and it goes down. So, something like that, okay? So let's determine the intersection points of this graph. Before we do that, let's examine the area. If I were to draw a vertical rectangle between these two graphs, is there a distinct top and bottom to that rectangle? Yeah. And so a vertical rectangle is going to work, and it has thickness of dx. However, if I drew a horizontal rectangle, is there always a distinct left and right? That would have thickness dy. So from the very beginning, you want to understand the space that you're working with. Again, a horizontal rectangle would, the right side would be a parabola, and the left side would be the same parabola. If you subtract them, you would get 0. Whereas the vertical rectangle, the red is on the top, the black is on the bottom. We're going to get a distinct height then. So dx is what we're looking for. So that means that our integral, everything will have x. So let's solve for our intersection points in terms of x. Our intersection points will set the two functions equal to each other. X squared minus 4x plus 4 equals negative x squared plus 20. I'll add the x squared over to get a 2x squared. I will subtract the 20 over to get a negative 16. I'll factor out the 2. This factors to x minus 4 and x plus 2. So I have 4 and negative 2. Let's go back and reference our graph. Does it seem reasonable that this intersection point could be at negative 2? Does it seem reasonable that this one could be at 4? Yeah, my graph isn't great, but, yeah. So seems like negative 2 and 4 is reasonable. So therefore, I have an integral, and it is dx. Thickness dx. So therefore, I have negative 2 to 4. And I'm going to have the red function minus the black function. Yeah, negative x squared minus an x squared would be negative 2x squared. And then if you have 0 minus negative 4x, you get a positive 4x. And 20 minus 4 would give me 16. So I didn't write out the two functions and subtract them simply just because I'm trying to conserve on space here. What is the antiderivative of negative 2x squared? Plus? So 2x squared plus 16x evaluated at 4 and at negative 2. I type in 4. What is 4 cubed? 64 times negative 2 is negative 128. So I get negative 128 divided by 3. Again, you want to try to do this without a calculator because there will be a portion of your test where you will not be able to use a calculator, even for computational purposes. And the silent screams are heard. Plug in 4. 4 squared is 16 times 2 is 32. If you pay me, 16 times 4 is 64, $100. I type in -2, -2 to the third, -8 times -2. So I have 16 thirds. -2 squared times 2. And then a minus 32. What is -128 minus 16? Negative 144 over 3, which is divisible. You get -48. Okay. 32 plus 64, 96 minus 8, 88 plus 32, 120. As Darren said, -144 divided by 3 is -48. If we add 120 to that, we get so the exact area bounded between these two curves is exactly 72 units, which is kind of cool. Two. So Sarah is not impressed. What Sarah would like to do is instead of using the definite integral, did you want to do the infinite limit of Riemann sums instead? What would I need to do to impress you, Sarah? Problem 2 will be dx as well. Caleb? What? I have -128 and -16. I took -120 over 3 and minus 16 over 3. I get -144 over 3. What did you get? Okay, got it. All right, so the second one will be a dx problem. The third and fourth one will be dy. You will have to integrate rectangles that are drawn horizontally, so you'll have thickness of dy. Those will be more challenging for you. You're going to want to make sure you check that answer key. Don't feel bad if you get a problem wrong. Work through it and figure out what mistakes you made. Let's look at problem number 5. Number 5 says, graphic calculator will be required for problems 5 through 8. It says, consider the functions e to the x and y equals 6 minus x squared. Draw the curves in the space provided. So let's figure out what that looks like. I've got e to the x, and I've got 6 minus x squared. I'm going to draw that graph. Because I had an excellent college algebra experience, I remember that the graph of e to the x looks like this. And I remember that 6 minus x squared looks like this. So no big deal about drawing the graph. The calculator simply confirms what we already knew. We want to find the intersection between them. I think that all the problems I've lined up for you for this section you're going to do them all with respect to dx, okay? So if you draw that vertical rectangle, you can see you have a distinct top and a bottom, whereas if you drew them horizontally, that would not be the case. So dx is going to be our basis for our operation, okay? So the problem says find the x values of the intersection of the curves to 3 decimal places. So I do the intersection. So that's partly why I want you to do this, because although the problems in the AP exam are going to be a little bit more involved, we'll talk about what that will look like. I want you to get used to using these operations. So intersection, I'm going to go close to the first and second curve. Enter, enter, enter. Get that negative 2.431. And then I do the intersection again. And I get negative 1.9398. Sorry. Positive 1.398. So the x value is my intersection. I really should have written more space, or left more space here, but it says write an integral. I'm going to write the integral here. So my bounds are from negative 2.431 to 1.398. What's the top curve? 6 minus x squared. And what's the bottom curve? dx. Now, we don't really have the algebra skills at this point to be able to find those intersection points. That's why we had to use our calculator. Whereas the first problem, we were able to find the intersection, right? So that's part of what I want you to understand, is that sometimes you can use it, sometimes you can't. So I'm going to insert 6 minus x squared minus dx. Delete, delete, delete. Second, calculate. What do I calculate? Number 7. Thank you, Wally. Negative 2.431 and 1.398. Now, I want to be clear that the transformation that we used with this obviously is not our original graph, is it? This represents the area. We should just get positive area. If you ever get negative area, there's something wrong with your bounds or the way you typed it in. So hopefully as this drags across, yep, it's just that upper portion, because area between two curves will always be positive if you just think about it. And so our answer is, we'll go to 3 decimal places, 13.315. And there are no units. Often on the AP exam, there aren't with these type of problems. We'll get to problems later where there are. That is your answer. But I just want to show you a small extension of this problem. Not that we're going to do it, but that you would understand what we're going to get to at some point. The AP exam will say, well, suppose that there's a vertical line that divides the area exactly in half, x equals k. Somebody tell me when you feel like I've divided the green area exactly in half. You want to be that person, Kels? Okay, D. Weiland, you want to do that for me? Jonah, you want to do that? Okay, somebody do it. Who's going to do it for me? Okay, great. You tell me when you feel like I've divided that area exactly in half. Okay, the question is, what would that k value be that would divide that area exactly in half? And what we can do is, we can, number one, we can write an integral that shows us how to calculate that. And number two, we can actually calculate it. So that's an extension of this type of problem that we'll look at later. There's other ways to create extensions off of this as well. They actually also ask you to draw heights off of this that will create a 3-dimensional shape that we find the volume of. And we'll get there. Conceptually, it's difficult for us to deal with right now, but trust me, we'll get to that. So this is a very basic basis for things you're going to be asked to do in the future. You've now done 2 problems. You have 6 left. I do not have an answer key written yet. I was grading your tests. Kelsey is extremely excited to get her test back, so I'm just going to leave this video, and we're going to go to